Hello friends, welcome back. In this tutorial, we will study about a CPU scheduling algorithm Fcfs. So what is Fcfs? Fcfs means first come, first served. Right. So what happens in this CPU scheduling algorithm? The process which requests the CPU first, that process will be allocated the CPU first, right? And this FCFS policy is managed by FIFO-Q, right? So what is a FIFO-Q? FIFO-Q means a first in, first out queue, right? So what happens when a process it enters a ready queue, then its PCB means its process control block is linked to the tail of queue, right? And then what happens whenever the CPU is idle or free, it is allocated to the process which is at the head of this queue, right? And then running process is removed from the queue, right? Now this first come first served CPU scheduling algorithm is a non-preemptive. This FCFS is a non-preemptive CPU scheduling algorithm. So what is the meaning of being non-preemptive? In this case, what happens once the CPU, right? Once the CPU is assigned to a process, then the process will keep the CPU, right, until it releases the CPU by terminating or by switching to the waiting state. Right. So what happens? This FCFS is a non-preemptive CPU scheduling algorithm. Right. So in this case, what happens once the CPU has been allocated to the process will keep the CPU until it releases it, either by terminating or by switching to the waiting state. Right. Now, suppose there are three processes, P1, P2 and P3, and they arrived at time 0, right? And burst time for a process P1 is 24 millisecond, and for process P2 is 3 millisecond, and for process P3 is 3 milliseconds, right? Then what happens? Suppose they have arrived in this order. First P1 has arrived, then P2 has arrived, then P3 has arrived, right? So they all have arrived at time 0, but they have arrived in this order, P1, P2 and P3. So first of all, what happened? CPU will be allocated to the process P1, right? So at time 0, CPU is allocated to the process P1, right? Burst time of process P1 is 24 millisecond. So up to 24 milliseconds, the CPU is allocated to the process P1, right? Up to 24 milliseconds, the process P1 will be executed, right? And after that, CPU will be allocated to the process P2, right? Now the burst time of process P2 is 3 milliseconds. So up to 3 milliseconds, CPU will be allocated to the process P2. So at time 27, right, process P2 will release the CPU, and after that CPU will be allocated to the process P3, right? Now the burst time of process P3 is also 3 milliseconds. So CPU will be allocated to process P3 up to 3 milliseconds. So at time 30, right, process P3 will release the CPU, right? Now in this case, see, the process P1, it doesn't have to wait, right? Its waiting time is 0. Right. And the waiting time of process P2 is 24, right? Because the process P2 has been started at time 24, so its waiting time is 24, right? And for process P3, the waiting time is 27, right? So what happens here, the average waiting time, so what will be the average waiting time? It will be 0 plus 24 plus 27 by 3, right? And it will be 17 milliseconds, right? So in this case, the average waiting time is 17 milliseconds. Now consider that if these processes P1, P2 and P3, they have arrived in this order: P2, P3 and P1, right? Then what will happen? First, the CPU will be allocated to the process P2, then it will be allocated to the process P3, and then it will be allocated to the process P1, right? Now see this. First, the CPU is allocated to process P2. At time 0, CPU is allocated to process P2, right? And what is the bus time of process P2? It is 3 milliseconds. So up to 3 milliseconds, CPU is allocated to process P2, right? After 3 milliseconds, process P2 will release the CPU, right? And then what will happen? CPU is allocated to the process P3, right? Bus time of process P3 is also 3. So CPU is allocated to the process P3 for 3 milliseconds, right? Then at time 6, right? At time 6, P3 will release the CPU, and after that, right, CPU will be allocated to process P1, right? And the bus time of process P1 is 24, right? So this CPU is allocated to the process P1 for 24 milliseconds, right? So at time 30, right, this process P1 will release the CPU. Now see what is the waiting time in this case. The waiting time of process P2 is 0, right? Waiting time of process P3 is 3 milliseconds, right? Because process P3 was started at time 3, right? Now what is the waiting time of process P1? The process P1 was started at time 6, so its waiting time is 6. Now what will be the average waiting time in this case? The average waiting time in this case will be 0 plus 3 plus 6 divided by 3, and it will be equal to 3 milliseconds, right? Now you can see that here in this case the average waiting time is 3 milliseconds, and in this case the average waiting time is 17 milliseconds, right? So in this case average waiting time is more, right? And here the average waiting time is less. Why it is so? It is only due to convoy effect. So what happens whenever the process with the large bus time is executed first, right, then there is a convoy effect, right? So what happens whenever a process with the large bus time is executed first, then all other processes have to wait for that process to get off the CPU, right? And this phenomena is called convoy effect.